Hello everyone, welcome back to another video. My name's Jared Beckwith, and since I'm an EEG technologist with experience in recording brain activity and decoding these neural signals, I thought I'd give my reaction to Neuralink, some cute little monkey that can control a computer simply by using his mind.
This is Pager. He's a 9-year-old macaque who had a Neuralink placed in each side of his brain about 6 weeks ago. If you look carefully, you can see that the fur on his head hasn't quite fully grown back yet. He's learnt to interact with a computer for a tasty banana smoothie delivered through a straw. We can interact with the Neuralinks simply by pairing them to an iPhone, just as you might pair your phone to a Bluetooth speaker. The links record from more than 2,000 electrodes implanted in the regions of Pager's motor cortex that coordinate hand and arm movements.
The primary motor cortex is what controls all of your movements, all of your limbs, and it's located in the center part of the brain, this red highlighted area right here. If you're familiar with EEG, hooking up electrodes to the patient's scalp, then this area of the brain is going to be found in the center electrodes, or the Cs. So there's also a very important normal variant that goes along with this motor cortex. And if you guys know what it is, leave it in the comments before I talk about it.
Neurons in this region modulate their activity with intended hand movement. For example, some might become more active when he moves his hand up, and others when he moves it to the right. By recording from many neurons and feeding their activity into a decoder algorithm, we are able to predict Pager's intended hand movements in real time. First, we calibrate the decoder by recording neural activity as Pager uses the joystick to move a cursor to targets presented on the screen. As he's playing this game, we are wirelessly streaming, in real time, the firing rates from thousands of neurons to a computer. Using these data, we calibrate the decoder by mathematically modeling the relationship between patterns of neural activity and the different joystick movements they produce. After only a few minutes of calibration, we can use the output from the decoder to move the cursor instead of the joystick. Pager still moves the joystick out of habit, but as you can see, it's unplugged. He's controlling the cursor entirely with decoded neural activity. Our goal is to enable a person with paralysis to use a computer or phone with their brain activity alone. Because they wouldn't be able to move a joystick, they would calibrate the decoder by imagining hand movements to targets.
A person who's completely paralyzed, a quadriplegic person who's completely locked in and isn't able to move any of their limbs, they can still calibrate this machine simply by thinking about making these movements. Although their arms won't be moving, by thinking about these movements, you will be able to calibrate the machine. Now, this easily can be explained if you're familiar with EEG and you know about the mu rhythm. Here's an example of the mu rhythm found on an EEG. So it's found in the center of the brain, right where the motor cortex is, the C3, C4 area. And if you want to make this rhythm attenuate or go away, you can ask the patient to clench their contralateral hand and make a fist. So let's say, for example, in this case, you see the mu rhythm in the C3 area. That's going to be on the left side of the brain. You're going to want to ask the patient to clench their right hand, make a fist, and the mu rhythm will go away or attenuate. While most people in the field of EEG are familiar with the mu rhythm and how to make it attenuate by clenching or moving your opposite hand or limb, not as many people are familiar with being able to make this mu rhythm attenuate simply by imagining moving the opposite hand or limb. So that's pretty interesting, I thought, and that's how this works with a paralyzed person, because it's just simply the thought.
One of the things the Neuralinks allow Pager to do is to play his favorite video game, Pong. To control his paddle on the right side of the screen, Pager simply thinks about moving his hand up or down. We've removed the joystick altogether. Now that he's up to speed, let's increase the difficulty and see how well Pager can play with the Neuralink. As you can see, Pager is amazingly good at MindPong. He's focused, and he's playing entirely of his own volition. It's not magic. The reason Neuralink works is because it's recording and decoding electrical signals from the brain.
One of my favorite quotes is, "Any sufficiently advanced technology is indistinguishable from magic." Now, this is exactly what it looks like. Magic. How could this even be working? So that's one of the reasons why I got into EEG in the first place, because I was interested in how I could connect my brain to a computer. And in order to do that in the year 2050 or 2077, whenever it's available to people who aren't quadriplegic, totally paralyzed, that's where it's going to start. But in the future, it's going to evolve to normal people, and we're going to be able to do amazing things with our brains that is connected to computers. By having a high bandwidth connection between brains and computers, we're going to essentially make ourselves artificially intelligent. We have already done that kind of with our phones, but when you want to look up a question on the computer, you have to type it in. It's very slow. We want to make that connection faster.
Great game, Pager. And what better reward for a monkey than a banana? We still have challenges spanning many fields of engineering. So if you're good at solving hard problems and want to change people's lives, even if you've never worked with the brain before, we would love to hear from you.
My name's Jared Beckwith, and as an EEG technologist, I work primarily with epilepsy patients, recording their electrical brain activity for neurologists so they can both diagnose and treat their epilepsy. So one thing that I think these Neuralink electrodes would be helpful for is in pre-surgery workup for epilepsy patients. So epilepsy patients, the epilepsy doesn't always happen on top of the brain, on top of the cortex, which is what EEG is best at recording. So sometimes doctors need to record deep into the brain structures by using SEEG or stereo EEG with implanted electrodes. So I'm familiar with patients having implanted electrodes just like this monkey has. If previously you've been wondering, wait, but why are you so obsessed with EEG and epilepsy, Jared? Well, here's the answer. Back in 2017, I decided that I wanted to write a book. I didn't know how I was going to do it or what book I wanted to write. I generally just wanted to write the story of my life. So I thought, hey, I need a video editor and a thumbnail designer. I didn't find either of those, and I just taught myself how to do it. 3 years later, after exploring my interests, coming up with many different book titles, I decided on Outwitting the Grim Reaper. That's my book title. So there's 3 parts in this book. Part 1 just started in February of this year, 2021. Part 1 is Dr. Ion, or as I like to call it, Ion right now. So that is my EEG software company that uses artificial intelligence to decode and recognize EEG signals, primarily seizures, sleep states, all good stuff like that EEG technologists do every single day. So that's the first part. And then the second part is Neuralink. Neuralink is the company that connected this monkey's brain to the computer, and they plan on in the future connecting quadriplegic patients' brains to the computer as well, so they could do the same thing that this cute little monkey is doing. The third and final part to my autobiography or life story is the digital brain era. Now, this is very far into the future, but it's going to be a fantastic future that we're all going to build together. I just have to get this first part done, Dr. Ion. Once I get that done with my team of engineers that I've been building, I'm going to keep adding more and better engineers to the team as I get more experience in managing people and working together to build amazing engineering products. So after that, I'll work with Neuralink. That's the second step. And then the third step, we go into the digital brain era. Wow. This is a fantastic future, guys. I'm so excited for it. If you're excited for the fantastic future we have ahead of us, hit that like button. Thank you so much for watching. Leave some comments down below. I really appreciate your feedback, and I will see you guys on the next video. I'm going to go eat a banana just like this monkey, and you guys have a wonderful day.